Hello RGL3300 students, back today again for our lecture for post-market surveillance course. You will have noticed that I've also posted that we've extended the time limit for your research papers for this course until the 24th at 11:30 in order to account for the obvious delay we've had this week with COVID-19, but also to comply with the college with respect to no assignments due this week. Okay, so that should help a little bit with the adjustment. Today I'm back to lecture on control systems for all industrial chemicals. You recall the last couple of lectures we've dealt with pharma and with pesticides. So today we'll be dealing with industrial chemicals, which is a unique situation because, as you know, pharma occurs in a relatively controlled environment. Pesticides and agricultural chemicals less so, but still the purpose is more defined. Whereas with industrial chemicals, they're virtually everywhere. They become more prominent as we've seen greater chemical intensification of our societies. And the challenge of managing industrial chemicals is more diverse, more complex in many ways. And we've seen that in terms of also how the issues have evolved over time in terms of industrial chemicals. So let's get started. I'll go through the early parts a little bit more quickly. Suffice it to say that the evolution of our understanding of industrial chemicals has evolved in such a way that we now understand that industrial chemicals are sort of a much more complex transboundary issue than a lot of the other environmental problems that we have. In the 1960s, 1970s, we often thought of industrial pollution issues, which are basically originating with industrial chemicals, were largely local issues. You know, the local river was becoming eutrophied, or the local lake because of fertilizers. There was smoke coming out of the smokestack of the local industry or things like that. But it didn't take long to disimbue ourselves of the fact that these issues were no longer local issues. They were also becoming regional issues. What showed us that really was the contamination of the Great Lakes. We began to discover that Lake Erie, for example, was becoming almost a dying lake due to eutrophication and other chemical contamination. Other aspects of the Great Lakes were being damaged in a significant way. So therefore, very quickly we found out that these were not local issues. They were broader regional issues. And when it came to the Great Lakes, they were actually international issues. And so we began to look for different ways to understand the industrial chemical problems. Okay, and not surprisingly, as we come up through the 1960s and into the 1970s, and we have publications like Rachel Carson's Silent Spring, by 1971 we realized that we needed a dedicated environment department in the Government of Canada, and that department would have, from its origins, a very strong focus on chemical contamination. Then by 1972 we had the Great Lakes Water Quality Agreement with the United States to deal with the rapid decline in the quality of water in the Great Lakes. And then as our learning began to occur on how chemical contamination was happening in the Great Lakes, we then began to discover that, wait a second, there's also some major regional issues that are emerging that became international issues with acid rain due to the burning of fossil fuels, coal use, mining, things like that. We began to get acid rain, which began to kill off a lot of our inland lakes through SO2 and NOx, the primary precursors of acid rain. So by 1991, we established a Great Lakes Air Quality Agreement between Canada and the United States. But the story didn't stop there. Then we began to realize that a lot of the chemical contamination that we were seeing in the Great Lakes and in other lakes and in the ecosystems more broadly and wildlife were actually not only local, regional in origin, but were global in origin. we began to find chemicals like toxaphene, DDT, PCBs were being released in relatively small quantities, but they were showing up in our environment even if we were not using them anymore. So we found them in our polar bears in the north, our own indigenous people in the north, our Inuit peoples, in our Great Lakes, in our inland lakes, in our river systems. And this was from sources that were thousands of miles away. So we began to realize that not only did we need to act locally, did we need to act provincially and federally, but internationally with the United States and now globally. And scientists encouraged that because we were starting to see population declines in species such as bald eagles, cormorants, osprey, you name it. We began to see a number of different impacts. In 1978, a new Canada-US agreement was signed in which commitment was made to dealing with persistent toxic chemicals. And this continued on, and those discoveries in the 70s and the agreement in the late 70s began to orient a lot of the work of both Canada and the United States on toxic, persistent, and bioaccumulative chemicals. And so we began to do a lot of research into these types of chemicals because of their ability to accumulate up the food chain and travel thousands of miles through the grasshopper effect because of their persistence. And so, and of course, those bioaccumulation and persistence was basically a way of transferring toxicity further up the food chain with the predictable negative impacts on ecosystems and on humans. So in 1988, Canada adopted the Canadian Environmental Protection Act, primarily to enhance legislative and regulatory capacities to deal with chemicals. And however, by 1988, we had already built up a significant legacy of pollution related to industrial chemicals and a significant legacy of chemicals on our market for which we had no life cycle data, no data about their persistence, toxicity, and bioaccumulative qualities. So in 1992, the government started to develop legislative and policy instruments to deal with these problems, and the Canadian and the federal government moved very quickly to develop the capacity to understand what we're doing with chemicals now. Where are they? How much do we have on our market, and so on. So in 1992, the federal government issued a call to Canadian industry to report all chemicals that were manufactured or imported into Canada. This call allowed for the development of a national chemicals inventory known as the Domestic Substances List, which you've heard about before. On May 4th, 1994, Environment Canada published the DSL in Part 2 of the Canadian Gazette, or the Canada Gazette. At that point, we had we'd accomplished a lot because now we knew what chemicals were on our market. So anything that was not on the DSL became a new chemical, okay? So that was the starting point of being more rigorous in analyzing the issues with industrial chemicals. And then during this period, SEPA was also going through a review of the legislation, of which my firm was involved, and we began to look at ways to revise SEPA to account for some of the new discoveries we were discovering about industrial chemical risks. So SEPA 99 became a new version of SEPA. And SEPA 99 allowed us to begin to say things like, these are the chemicals that are on market. We're going to have to go back and review what we have there. But any new chemical that is not on the DSL, any chemical that is not on the DSL now is a new chemical to Canada, therefore must go through pre-market approval. Okay, on slide 14, you see SEPA's definition of toxic chemical. And so that became a driving characteristic. So, SEPA and the DSL together enabled the government to establish a regime for control of new substances. According to SEPA 99, a new substance is one that is not on the DSL. The New Substance Program is responsible for administering the New Substances Notification Regulations and the New Substances Notification Regulations organisms of SEPA 99. First is chemicals and polymers, the second is organisms. All right? And these regulations were created to ensure that no new substance, chemical, polymer, or product of biotechnology is introduced to the Canadian market before a risk assessment is done and control measures defined as required. When Environment Canada receives a notification from a company or individual, the department carries out a joint assessment with Health Canada. All right. The assessment process results in one of the following outcomes: a determination that the substance is not suspected to meet or be capable of meeting the criteria of toxicity as defined under Section 64 of CEPA, a suspicion that the substance meets or is capable of meeting the criteria of toxicity as defined under Section 64, a suspicion that a significant new activity may result in the substances meeting the criteria of toxicity. You'll notice in these criteria, there's the characteristics of the product, there's the characteristics of the use, and then there's the characteristics of whether that use is going to change. So a substance could be approved for the Canadian market subject to very strict limitations on the amount, on the type and quantity of use. And then if the type and quantity of use is going to change, that substance may be required to go through a subsequent or an additional review. Okay. Substances suspected of meeting the criteria of Section 64 of CEPA 1999 may be controlled by one of the measures set out in the Act, including conditions on the import, manufacture, use, or disposal of the substances, prohibition of import and manufacture, prohibition of pending the submission and assessment of additional information. So, and this can change. I mean, if the uses are going to be changing, then the government could require a completely new review. All right? If there is no suspicion of toxicity, but there is suspicion that a significant new activity in relation to the substance may result in the substance becoming toxic, the substance can be subject to a new notice, as I said. All right? So in this way, there's sort of some differences between the industrial chemicals review processes and those of the other classes of chemicals. Section 76 of CEPA 1999 requires both the Minister of Environment and Climate Change Canada and the Minister of Health to establish a priority substances list. This list identifies substances to be assessed on a priority basis to determine whether they are toxic. Okay, and this is what we did with the DSL. We went back over the 23,000 chemicals. We broke them out into classes, and then we did computer modeling to determine their potential relationship to CEPA's definition of toxicity. If it looked that something may be subject to, may need to be determined to be toxic, then that substance would have been put on the priority substances list. Okay. And the PSL gives you 5 years to deal with any regulatory measures or any control measures that may be considered. Okay, so then substances that are determined to be toxic from the PSL get put on the list of toxic substances. Once a substance is placed on the toxic substances list, preventive or control actions such as regulations, guidelines, or codes of practice are considered for any aspect of the substance's life cycle from the research and development stage through manufacturing, use, storage, transport, and ultimate disposal or recycling. Under 65.3 of CEPA, virtual elimination is considered for any substance found to be toxic, persistent, bioaccumulative, anthropogenic. In other words, not natural substances. Okay, this involves pollution prevention strategies to prevent measurable release of a track one substance. A track one substance that cannot be managed successfully throughout its life cycle will be targeted for phase out of generation and uses. And this is essentially what we did with the compounds that became the subject of the Stockholm Convention, the original Dirty Dozen. We had already eliminated them through this process before the Stockholm Convention was in fact negotiated and signed. Okay? So these the processes that industrial chemicals go through are somewhat more nuanced because there's so many industrial chemicals. They have so many uses. They have benefits that can be quite diffuse, depending upon the chemical. So the dealing with industrial chemicals deals not only with the hazard, the exposure related issues, but very strict definitions of what type of use, what quantity of use, and so on that needs to go into it. And at the same time that we have this complexity in approving industrial chemicals for the market, we also are somewhat limited in terms of how we can do post-market surveillance. Later on, we'll be talking about how we do post-market surveillance of industrial chemicals through environmental and biomonitoring. Because there are no controlled systems like we have with pharma in terms of a direct pipeline of post-market surveillance, or even in pesticides where it's more of a passive system, but the audiences using the substances are somewhat more discreet, right? There are farmers, there's cities that allow it on lawns and so on, but a lot of that has been restricted. But because the use is more specific for an agricultural or a growing purpose, a weed control purpose or a pest control purpose, we're able to track these substances more easily. Industrial chemicals, there's literally thousands of them, and they have hundreds and hundreds of uses in hundreds and hundreds of different locations. So tracking these becomes somewhat more difficult. So we have different kinds of reporting mechanisms that are required, and the requirement that we do environmental and biomonitoring to deal with industrial chemicals. Okay, so go through the slides on this, make sure you understand what's going on there. Later on we'll be talking about environmental and biomonitoring. Okay, so keep going, get your papers done by the 24th now, and I'll be back, and we'll be back next week for both our Zoom calls, for which you have them in your calendar now, and then we'll probably be doing some additional lecture videos as well, so we don't fall behind in that area. So hopefully talking to you all next week. Keep going, keep positive. Let's not have things pile up at the end of the term. Let's finish the course. Let's graduate. Okay? Talk to you later. Bye-bye now.